And we're live? That sounds good. Hi, everyone, to the first Starport Community Call.
Hello.
So there's a few things I will post in the announcement section. We have a new Starport Discord. So if you're interested in getting involved on Discord, you'll want to join the Starport Discord channel. We also have a mailing list. So if you're interested in receiving Starport news, reminders about the Starport Community Call, the Community Call calendar, you'll be able to sign up there. And every month we'll open up an issue on GitHub that will give a tentative agenda. And then we hope that the community starts to add their own items to the agenda so that it's not just Dennis and Tobias and the Starport team talking, but it becomes an interactive event and people contribute. So those will be in the announcement section. Also, we have a small poll for the people who are on the call. So I'm just going to give us a second to answer it. Can you guys see the poll? I hope so.
I can see it.
Hopefully they can too. So if you guys just vote for a second, that would be helpful. And we'll probably do this every month just to get an idea of if you've heard of Starport, if you're using it, if you've never heard of it before and you somehow got here. I'll close it in a second. But the last point is, if you have questions, please raise your hand and a group of us are here and we'll bring you into the stage, and Tobias and Dennis can hopefully answer your questions and we can create also a small discussion. So I'm going to close the poll, but it looks like 71% of you guys are using Starport. So that's good. Okay, so that's that. And without further ado, I'm going to hand it over to Dennis and Tobias to take it away through the agenda.
Cool. Thanks so much, Michelle. I guess what we'll start with is me sharing my screen, and then I'll explain what we're going to do on this pilot episode of the Starport Community Call. So let me share my screen. You should be able to see it now. Okay. So what we're going to do today is basically I'll first talk about Starport a bit, even though according to the poll, most of you know what Starport is, but still it's worth repeating it, I guess. Basically, Starport is right now it's a CLI tool that allows you to create a new Cosmos SDK blockchain, and it allows you to add features to it, start a node in development. It has a built-in relayer. It can generate code. It has an ability to scaffold view application, and yeah, it's very feature-packed, and it's definitely the best way to start building IBC-enabled blockchains. And you can visit it at github.com/tendermint/starport, source code, and of course you can install it on your system, or you can use it in a web-based IDE. I'm going to be using it on my local machine, and to install it, you basically need to curl a script. So curl get starport.network/starport bash. So this will download the latest release of Starport. I already have it installed, but of course you can always go to starport.network docs and read how to install Starport from here. So it's essentially just one command you paste in the terminal, and now we have a Starport binary. And Starport binary does great many things. I'm not going to go through everything, but last week what I wanted to do is test out features of the latest Starport V18 And I thought about like what can we build today, and I realized that a loan module might be an interesting project to build. So that's what we're going to do right now. So any project you start with Starport pretty much involves scaffolding a chain, and we're going to call it Cosmonaut.
Someone from the chat is asking to increase the font. Can you? Yeah, perfect.
Yes, I'm reading your mind as we speak. And yeah, if something is unclear, please ask questions, and maybe Tobias or Michelle could relay them to me. But yeah, let's scaffold the chain. For some reason, I called it Mars. I should have called it Loan. So let's just remove Mars. Mars is just, we use Mars for random chains, but this is going to be called Loan. And also one more feature. Let's do it properly. Basically, Starport scaffold chain has several options, and the one we need is no module. So by default, Starport scaffolds a chain with a module, but we don't want that because we're advanced users. We want a chain without anything. And I'll explain why exactly we want that. So let's wait for a couple of seconds for Starport to do its magic. And what we will get as a result of this is a chain. And we'll open it in VS Code, my editor of choice. And I'll also increase the size of the font so everyone can see it. So this is the default structure of the chain that you get. Right now, it doesn't have much. It's pretty much all in the app directory. Let's do the first step, and the first step is almost always creating a new module, because that's how you group functionality within Cosmos SDK blockchains. So blockchains are built out of modules, right? So of course we also use Starport scaffold module, and we'll call it a loan. And let's see what kind of functionalities module scaffolding has. We're interested in a flag called dep, and dep essentially accepts a list of modules, and our module is related to loans, right? Like I'm going to explain shortly what this module does, but right now let's just scaffold a module for it. We know that it's going to depend on bank. We need the bank module because it's a loan module. It just makes sense that we depend on the bank module. And while it's scaffolding, let's go through like what's the purpose of this module? What is the functionality we're trying to implement? And the functionality is very simple. It's essentially to allow people to create requests for loans. So I want to loan a certain amount of tokens, and I create a loan. And then another person who has this amount of tokens, they approve my loan, thereby transferring the amount from their account to my account. And it's going to become more obvious once we start working on it, the structure of it and what kind of actions users can take. But the basic premise is that people can create loans, can request loans, can approve loans, repay them, liquidate them, cancel them, things like that. So essentially for borrowing tokens from other users of the blockchain. So what we've done is we've scaffolded a module. It's just boilerplate code, no functionality here. And the cool thing is that we can actually see what has changed. We're not going to pay attention to the app directory because it's not really relevant to what we're doing, but we'll definitely look into the proto directory and the X directory. And proto just describes the data types that we have in our application. Right now, it's pretty much empty, just a couple of placeholders. But we will see how it changes after we scaffold code. In the loan module, nothing much. It's just boilerplate code. What I do like to do is after scaffolding something and before scaffolding something else, what I do is I add and commit scaffolded module. Sometimes I actually paste the command that I used, but this helps me to kind of clean the sidebar and see exactly what's going on, what has been scaffolded by Starport. So we've created a module, that's all well and fine. Now let's actually dive into functionality. So when modeling applications, blockchains, we need to think, well, I mean, I try to think in terms of types, right? Like what kind of types of data my blockchain application will be operating with, right? And in this case, it's pretty simple. It's a loan, right? So we can use Starport to scaffold a list of loans. So let's inspect all the scaffolding commands we have. Well, chain is kind of self-describes a module. We have a list, map, and single, and it scaffolds CRUD for a particular type. And most commonly used commands are list and map. And it's exactly what it says on the tin, right? List is just a list, like an array of items. And map is well, it's not an array, but it's also a collection, but it's indexed by a key, right? So you have key value sort of store, and list is indexed by an incrementing integer, essentially. Well, I mean, I'm not being very precise here, but I'm just trying to kind of explain what goes on so that you can model your application successfully, right? In this case, we know that everything is just going to be a list of loans. So we do just that. We scaffold a list of loans, and then we need to specify all the fields that this loan will have, right? And let's just think about it, right? Well, you need a loan amount, and you probably also need a collateral, right? Collateral is something that you as a borrower post, and this collateral is held on by a module. And in case you can't repay the loan, this collateral goes to the lender, right? And we also need to think about the fee. So it's not free, right? You take a loan, you take someone else's tokens, and you want to you want to create a system where people who lend tokens are incentivized to do so. So that's why we also think about a fee. And what else? We also need a borrower. So this is someone who borrows tokens, right? And actually, let me. I mean, I have it all implemented. I'll put a secret, but I don't want to mess it up. Basically, we need to keep information about amount, collateral, fee, borrower, lender, and that's pretty much it. I think I didn't forget anything, but if I do, then we'll just roll back. What this command will do is, let's actually run this command. Let's run this command and see what it does. So it created a bunch of files, and it modified files as well. And if we go into TXProto, like it's very easy to see what the application does by browsing proto files. So you can see all the actions that a user can take and all the data types. So here we see that it created a loan type with all the data, and there are also actions that users can take, represented by messages. And this is very useful if you want that, but in our case, we actually don't. We don't need these messages because we'll be creating our own. So what we're going to do is,
I think last time we created this app, we also had a state. I just looked this up.
Yes, we also had deadline.
Yeah, exactly. Yeah.
I remember that. Thanks, Tobias. You're going to be working with this application, so you're making sure that we're on track, which is good. So we need a deadline because at some point the loan becomes well, basically every loan has a deadline after which the lender is free to liquidate the loan and take the collateral. And we also need a state because a loan will change the state as messages get processed, and we want to keep track of that. So I think we have all the value, all the fields we need, and to prevent Starport from scaffolding all the messages and all the CRUD operations, we use no messages flag. No message flag. Hopefully that works. And inside TX now we don't have anything inside message, but we do have loan, and we should be good. So what I, again, like to do is add everything to Git, commit created loan, and now again we have a clean stage, no, not stage, well, we have a clean directory, and now we can think about all the actions. So we scaffolded a type, right, which is something that will be persisted to the store in a list-like fashion. And now we need to think about messages, right? And the way it works is messages, a blockchain processes transactions and includes transactions and blocks. And transactions include messages, and messages change state. So depending on messages, state changes differently. So you can think of messages as actions that that change the state of your blockchain application. So we will have quite a few of them, and one action, one message, and we have, of course, a command for scaffolding messages, which is Starport scaffold message. And the first argument is the name. So the first thing we need is request loan, right? And request loan will pretty much create a loan, right? So we need to pass most of the values that we store inside the loan. So first of all, amount, then the fee, collateral, deadline. We don't need to specify the borrower because every message has the signer information passed alongside the messages, I guess, as part of the transaction. So we don't need that. I mean, as part of the message, really. So we don't need that, but we do need the we don't need a borrower because we don't know the borrower yet. Deadline state we don't need. We will set that. I think that's pretty much it. Well, if it's not, then hopefully Tobias will correct me. But yeah, that looks pretty good. Let's treat a bit and see if we're doing all right. Yeah, we're doing all right. So we are creating a message. We're going to create all messages initially so that we know what we have to implement, and then we'll go ahead and implement the functionality.
Yeah, and here I'm to correct it. Do you have the state in request loan?
I don't think we need a state because we're creating a loan and we'll assign a state when the message is processed.
Got it. All right.
That's a good question. So let's scaffold another message, and another message would be, let's just think of it in terms of the life cycle of a loan, right? First you create a loan, then someone probably gonna approve it, right? So approve loan, and you already have the amount, right? So you don't need much information about approving a loan. So a lender is just gonna pass the ID. And what we do need is specify the ID and also pass the type. And this is just going to save us some conversion because when you pass an argument it's a string, but we process it as uint. It just saves us time to not have to convert it from string to uint. So let's wait for that to get processed. It takes a while because Starport actually does a lot of things, and one of the things it does is it actually generates a TypeScript client. We don't necessarily need it right now, but I'm not going to disable it, but it does that as well. So the next action is going to be repay loan, right? So once the loan is approved, the next step is to repay, and the same goes here. We just need to pass the ID. We don't have the functionality right now to partially repay, but I think that's actually an interesting piece of functionality you can add. So allow the user to partially repay the loan, so you would have another argument there, like amount that you want to repay. So it's definitely something interesting you can add, but not today. The next message is liquidate the loan, right? So if the borrower didn't repay the loan in time, the lender has the right to liquidate the loan. And again, we don't need to pass anything else, just the ID. And you can see already the files that Starport generates for us. We're actually not going to look into the types directly that much, except for expected keepers and probably errors. But yeah, we are definitely interested in the keeper. So I'm going to explain briefly what we're interested in here. But the last step is cancel the loan. I don't know if we'll have the time to implement it, but it's pretty straightforward. It's when a borrower decides actually not to get the loan, right? So they requested the loan, they posted a collateral, but then they decided that they don't really need the loan. So this is an opportunity for them to cancel the whole process and get back the collateral. So let's scaffold that as well. So as you can see, what we're doing here is essentially modeling the whole application, right? And that's exactly what I did when I was writing this. I just thought about like what kind of actions users might want to do, right? And like what types the blockchain application would be working with. And yeah, that's basically it. That's most of what you're doing when you're writing a blockchain application. You're thinking about the types, how they're stored, and messages. Right now that we have everything, let's add everything to Git and say we've scaffolded messages. Okay, so now we don't need the terminal anymore. We should have, I think we scaffolded everything we need. A bunch of actions, a bunch of messages. So let's start implementing, and we'll start implementing from the request loan message. So right now we can actually build Starport chain build to see that it's working. It doesn't show any errors in VS Code, but let's do that anyway. Basically, the way Cosmos SDK blockchains are written is you define your application in protofiles, and Starport, of course, scaffolds them and modifies them accordingly. So we have a service for messages, and each message is an RPC in proto terms. You can like read all of this. And we have a type called loan, and in proto terms, it's a message, but it's not the Cosmos SDK message. Cosmos SDK messages are actually RPCs in proto. So proto lets you define types and your application at a high level in terms of types, and you implement the bulk of the application in the X directory, right, in the module, and particularly in the keeper. Like, we're not going to touch the client because the logic, the code that Starport has scaffolded is enough for us. And what we need is we need to define state transitions, essentially, right? And state transitions happen when messages are processed. So each transaction consists of messages, and these messages get routed to particular modules. And in this switch statement, a specific keeper method is called when a blockchain receives a particular message. So all of this routes to these files, essentially, right? So when someone requests a loan, this function gets called, and that's pretty much it, right? Pretty straightforward. And we can see that it successfully built the blockchain. Now we can go ahead and start implementing. So we will need context. And the first thing we need is we need to kind of deconstruct the message into a loan type, right? So we have a loan proto that describes the message, and Starport, when builds the chain, converts generates Go code from this message. And inside the types package, we have a loan type. So if we do types, we have the loan, right? And now we can create a loan essentially from the messages from the message that we're processing, right? So the first thing, we have an amount, and we pretty much just take the values from the message, and let's also assign it to variable loan. We're not using it yet, but we are going to be. So right now we're just taking values from the message, and deadline, message deadline. What else? Fee is also there. The next is state, right? And state we don't have as part of the message because this is just internal thing we keep track of, and it's going to be requested, right? That's the first state the loan can be in. And the next one is borrower, right? So we have the borrower and its message creator. So essentially, each message has a signer, and by default, it's called creator. In the newest version of Starport, you can actually customize this with a flag signer, but we didn't do that because that's all right. We can just use message creator here. We're not going to specify lender because nobody has approved the message yet. So what we want to do right now is we want to, like, after we created the loan, what we need to do is we need to actually do something about it, right? Like, we need to make some state transitions. So the first thing that has to happen is we need to transfer the collateral from the borrower to the module account. So yeah, let's do that. So first we need to get borrower's address, and we're going to use SDK ACK address from batch 32, and we'll take message creator because that's the borrower. And now we need to transfer tokens from an account to the module account. And let's actually find how we do this from Cosmos SDK. So basically, Cosmos SDK has functions, and I don't know if that's the right thing to do, but that's just the way I do it. So send coins from back.
Dennis, we have a quick question.
Yep.
The question is, what about the field types? You probably don't want them all as strings.
So right now, yeah, we do support several types, including like integers, booleans, and strings. The next version of Starport is going to include more types. right now, we're treating everything as a string, which is fine for our purposes. Like we just need to make conversions from strings. This is not ideal, but you can change types later on. Right now, we're just using strings. So yeah, in the next version, you will be able to specify, when you scaffold the message, you can specify like a coins array, for example, instead of using a string. But right now, we're not doing that. So yeah. What I was trying to send coins from address. Okay, I guess that from account to module, from account to module. Okay, so the bank keeper exports essentially this functionality that we can use from our module. And this is just like the hacky way I'm doing it. I'm just looking how auth module essentially quote unquote imports this functionality from the bank keeper. And that's how I'm going to just do it. So in the expected keepers, I just paste that here. And this way, this function will be available to me. I also need to probably import SDK from Cosmos SDK types. For some reason, it didn't import it from me automatically.
I'm trying to follow you along. I'm not sure. Can you post the link or something? Like, how can I follow you?
How can you follow me here? Well,
I just also Google that or like GitHub search this. How was it? Get coins from account to module, right?
Yeah, send coins from account to module. I actually had to look it up as well. It's not the most straightforward name, but yeah, if you search this on Cosmos SDK, you should be able to see it.
Yeah, great. That worked for me. Thanks.
Okay, cool. Now let's go back and yeah, the next step is to actually convert collateral. So right now it's a string, but we need collateral. Let's convert this from string to SDK type coins. So we use parse coins normalized, if I'm not mistaken, and we're using message collateral. I mean, you could use loan collateral, but it doesn't really matter. And parse coins normalized returns an error. So I'm gonna do that right now for the sake of expediency. Let's just like not process errors, but you kind of know that you need to do that, right? Let's not do that right now. And what we're doing is we need to essentially use this function. I'm just gonna copy it and keeper, bank keeper. Okay, we have context, and we need sender's address as which has type SDK address, which is our borrower. So we send it from the borrower to the module account. So here we just need to specify the name of the module, and inside types we have module name. So basically, if we go into types and hold on a second. Yeah, it's called loan. So you could use a string loan, but we're just using module name so that if it changes for some reason, then it gets propagated here. And the amount is collateral. So what this will do is it will transfer collateral from the borrower to the module address. And we're not going to process the error right now. We should be doing that, but like we don't. And what we need, like if this works well, then we need to append the loan. So Starport has generated functionality for this. Let's look into the loan.go. So we have very useful functionality here, including append loan, which just takes the loan and appends it to the store. So you don't have to do all of this by hand. We're just reusing the card functionality that Starport has created for us, and we're passing context and the loan. So that should work, hopefully. I mean, it's live kind of programming, so things can go wrong. Let's actually start the chain and see if it works. So we're using Starport chain serve for that. And what Starport serve does is actually many things, but essentially it builds the chain. It's installed dependencies, build protofiles, builds the chain itself, initializes the chain with default params. It uses config YAML to set up the Genesis file and configure Starport in development, right? This is purely for development. You're not using config YAML for production. And yeah, it starts the node with hot reloading. So let's wait for that to work.
While we wait, so you're using a cool VS Code extension to that you can see into the functions, like which parameters are needed, and that you can kind of find out which functions exist, right? Can you show which module you're using for that?
Sure. If I knew, I would definitely.
I think you can just type Go, and then it would show installed modules.
So yeah, basically I agreed to everything that VS Code asked me. Like,
Okay.
this, I said just please everything.
Okay, cool.
So VS Code actually asks you whether you want all the things, and you just say yes, and it works.
Yeah.
So.
All right. I thought that would be a cool way to find this out. All right.
Well, I mean, let's see if we have it. Auto date views enabled. So I have these extensions. Okay, you can't search through installed extensions, but Docker. I have too many extensions installed, to be honest. I think it's
maybe
actually
via the Go, yeah.
Yeah, it's the Go extension, but it uses a bunch of Go programs. And I'm sure like Go programmers right now are screaming in horror at my not knowing like what the hell am I doing, but yeah, just use VS Code and agree to everything.
Yeah, cool.
So it built the chain, and now we can probably use it. So loand is the binary. When you do Starport serve, it builds the binary, installs it into your Go path, and you can now use loand, and you can send transactions. So hold on a second. Yes, so you can send transactions. You specify loan module. For some reason, this is very inconvenient. Yeah, so you have all the messages here, and most of them don't do anything except for our request loan message. So request loan message should allow you to create loans. And if we type, you see amount, fee, collateral, deadline, flags. So let's do amount first, which is let's go into config and see what kind of tokens we have. We have tokens creatively called tokens. So let's say 100 token, and the fee is going to be 2 token, and collateral is going to be 200 token, because collateral should be more than the amount. Is not enforced right now, but in theory it should be. And the deadline is in block height. So let's say 500, doesn't matter right now. We're not implementing it at the moment, and you also need to provide a from flag, which is like the common flag for all TX commands, which specifies who is the signer for this. So essentially, Alice is going to be the creator inside the message. So we agree to that, and it should get processed. And now we can do loan D, Q, loan, and we should have list loans. So this is something that Starport has scaffolded for us, like list loan and show loan. And we see that the loan has been created. So it looks pretty good. It assigned ID, it assigned the proper state. If we do it again, it should also work. So it created one more. So that's pretty good. And we can see that the borrower is Alice. So that's we've done something, which is good. So we've created a loan. Nothing special, but at least you kind of now understand how it all fits together, right? How all these things connect. And the next thing we're going to do is implement approve loan, and it's very similar in a way. Basically, first of all, we need to find the loan, and when you approve, you just pass an ID, right? So you first need to find the loan, and we have a function for this, which is called getLoan, and we can see that in the loan.go. Starport scaffolded getLoan function. So it's very useful. You just pass an ID, and you should get a loan back. So yeah, keeper getLoan. You pass context and message ID. And let's skip error checking. I mean, in the interest of time, let's not do that at all. And right now, what we need to do is we need to check that the state is requested, because like that's the reason why we have the state field inside the loan, is to make sure that we approve only loans that are requested and not the ones that have already been approved. So what we're doing is we just use a simple conditional. So if the loan state is not equal requested, then we just not panic, but we need to throw an error. So we return nil as the response, and then we pass SDK error, if I'm not mistaken. Hold on a second, let me check. So it's called SDK errors. SDK errors. And the error is going to be, for some reason I thought it would import it automatically, but it looks like it doesn't. So the SDK error is, hold on a second, let me import it. SDK errors. And Tobias, also tell me when we are running out of time so that we have enough time for you to implement all the cool functionality that you want. We can always copy paste some of the functionality.
How much time do we have in total? Is this 1 hour?
Yeah, we planned for 1 hour, but yeah. I don't know.
It's gonna be tough already. So we have like 15 minutes left.
Okay, that's.
And we haven't even opened up to questions. So.
Okay, well, it takes more time than I thought because I'm kind of going through everything. So maybe instead what we should do, like we've implemented like a simple thing right here. We can go through like existing code and go over functionality, I guess, because we don't want to waste more time than we planned. What do you think?
I'm open to that.
Okay, so I'm gonna go through what we've already kind of accomplished, right? We basically covered the functionality that we need to process messages, right? Like right now, you know where to add functionality and how to do it. And I mean, if I start typing everything, it will take us about like, I don't know, an hour more. So let's just go into the code we already have written for this and go through the logic. So yeah, we have the loan module already implemented here, and it's pretty much the same thing. So if you go inside the loan keeper, let me just clone it, I guess. Yeah, let me just clone it.
Can I just paste the link in the chat for the loan module?
Yeah, sure. So let's clone that. I mean, we've learned something. This is a pilot episode after all. So we've learned that if even a simple module, if you try to type everything, at least at the speed I am doing it, it takes hours.
And you're already very quick.
Oh, well, yeah, well, in any case, let's kill all of this that we have. I mean, we would have succeeded. I'm pretty sure of that. But it's more useful, I guess, to go over the functionality here right now. So we left our application here. So we requested a loan. Here we actually have some error checking, like very, very primitive error checking. But yeah, borrower collateral sending coins from borrower to the module account, and we're appending the loan. So after this message is processed, what happens is a loan is created. Now the next step is someone approves the loan, right? And we're actually not changing anything except for these files. So like you're not missing anything. You can view this on GitHub. Basically, when we approve the loan, what we're doing is we're getting a loan using the getLoan keeper function that Starport has scaffolded inside the loan.go file, right? And we throw in an error if it's not found. And then we're checking the state, like we need to proceed only if the state is requested. If it's not, then we throw an error again. And now what we're doing is we're getting lender and borrower from the message and from the loan respectively, because we know the borrower because it's stored inside the loan, and we know that creator is always passed alongside within the message. And we take amount from the loan again, because the only thing that we have in the message is the ID. Now we're using sendCoins bankkeeper method to send coins from the lender to the borrower. And that's actually like where the loan is, right? Like that's basically the logic behind the loan, where you send tokens from the lender to the borrower in a precise amount. And then you update the state of the loan, right? You update it with the creator as a lender, because now you know who approved the loan, right? And you change the state to approve, and you again set loan. And this is actually one of the beautiful things about Starport, is that it has all these functions that you don't need to write by hand, right? Like get loan and set loan. All of these getters and setters are implemented automatically for the types that you scaffold, right? And if it was something else, then it would have been something else here, right? Like get product count, and it takes all the types that you it takes all the fields that you use when scaffolding and intelligently scaffolds everything. So that's very cool. So when you approve the loan, it gets updated and tokens are sent from the lender to the borrower, right? The next step is a person decides to repay the loan. And of course, if we had to retype that would take a long time. So let's just go through the code. That was a good decision, I think. Again, we get the loan. We change that. We check that the state is approved, and if it isn't, then we throw an error, and then we proceed to actual functionality, right? We get all the values from the loan into variables, and then we basically send coins, right? So when a loan is repaid, what essentially happens is tokens are sent from the borrower to the lender, right? Back to the lender. You want to give the lender back the amount that they lended to the borrower, and you want to send the fee as well. And from the module account, you need to return the collateral back to the borrower, because it's no longer part of the transaction, right? Like collateral has to be returned to the person who posted this collateral. And you update the state in case, not in case, but you actually need to do that because state transitions depend kind of on the state of the object. and you update the loan using setLoan method. So the next step is to, I guess, liquidate the loan if it hasn't been repaid in time. And this is actually kind of interesting, right? So if the loan hasn't been repaid in a timely manner, the lender is allowed to liquidate the loan, which is basically get the collateral. And that's what we're implementing here, right? So what we need to check is that the loan lender is not basically, like, if it's not the same as the message creator, right? So the person, the entity who broadcasted the message should be the one that was set in the loan when it was approved, right? So basically, if it's not that, then you're not the lender, so you can't really proceed. You cannot take the collateral of the loan that you did not approve. Then we need to check that it has been approved, because if it's already been liquidated, for example, you can't really do that. Again, you can get the collateral again for the same loan, for example. And then you take lender and amount, and then you process the deadline, right? So we have the deadline set in loan, and we parse it as an int because we've recorded it. We stored it as a string. I guess we could also specify it as an int from the beginning, but we didn't, so we do that here. And here we just check that the block height, that the deadline, like the block height, is over the deadline. So you are, as a lender, you have the right to liquidate, because you can't really liquidate something that hasn't passed the deadline. And then you send coins, right? You send coins from the module to the lender. For some reason, it's amount. And now I'm thinking that this is probably a mistake, because it should be collateral. So this is probably an error here. So it should be collateral. And here, collateral. I think, if I'm not mistaken. So when you liquidate a loan, you send collateral amount from the module to the lender. Yeah, makes sense. So let's fix. Just push directly to master, because that's what we do. Okay, we fixed that, hopefully. And we updated the state. And the last message that we need to process is cancel. And here again, we check that that you are the borrower, and that's the only way you can cancel the loan, can cancel someone else's loan. And you also send collateral back from the module to the borrower. So here we send collateral from the module to the lender because the deadline has passed, right? And here we send collateral from the module to the borrower. So yeah, let's just try it out. Like the last thing we do here is let's try it out and see if it works. Starport chain serve. And I mean, this probably is going to be pretty useful for you guys to just read the source code. It's not the most beautiful source code there is, but it's implementing certain functionality that is useful, and yeah, you can use it to learn about how to build simple Cosmos CDK modules. So now that we have this loan D, TX loan request loan, and let's say 100 token, 2 token, 200 token, and the deadline is going to be 300 blocks. And from Alice. So now we should be able to query the loan list loan, and now we do again tx loan. Now we approve the loan. So approve loan, and we're going to do this from Bob.
Can anyone approve that loan once it's listed?
Yeah.
On the chain, yeah, right?
Yeah, anyone can approve. So the state now is approved. We have a borrower, which is Bob. Everything looks good. And now let's check balances. So query bank balances of the lender, and she should have, yeah, the lender has 100 tokens less because that's the amount, and the borrower should have more tokens. Okay, for some reason that's not the case. Hold on a second. Oh yeah, well, of course. I mean, because they also posted a collateral, right? So they posted a collateral of 200 tokens and they got 100 tokens back. So this doesn't really make sense when you post collateral in the same denom as you want to post amount, right? So the amount of collateral should be in different denoms, or at least, but you kind of get the point, right? 200 tokens collateral, 100 tokens amount, you get 100 tokens less. But yeah, we should have posted collateral as a stake, I guess. But I mean, this functionality still works. So what we can do is we can repay the loan. So loan, repay loan, 0 from, let's do Bob and get an error. Okay, interesting. So when we repay the loan, okay, well, I mean, it could use some improvement. When you repay the loan, we actually don't check that you are the same account. So we should have added the same check as we do here. So we can actually quickly fix that. So we need to do the same check when we repay the loan. So we do that.
But that would be basically cool donation, right? If someone just repays your loan randomly.
Yeah, Bob here is basically like a philanthropist. He just repaid the loan that Alice owes him.
Let's allow a philanthropist. So let's keep it open.
Let's fix this. But I mean, if you wanted to fix that, you would add this check here. So yeah, essentially that's the way it works. I mean, I still wanna do this to make sure that it's working. So let's let rebuild, and I'll commit that. But basically, you kind of see how it works, right? It's very straightforward, and we are running out of time, I guess. So yeah, this is kind of an interesting project. You can read through and add features to it. We're probably going to make a tutorial out of this, but yeah, in the meantime, if you want, you can create a PR and add functionality to this. So yeah, that's about it. We covered some of the most important things, I guess. Here we covered how to scaffold a chain, add functionality to it quickly with Starport, and where exactly you need to add a logic of your custom application. Right? In this case, it's just in the keeper. We've skipped some of the steps. I mean, we covered some of the things here. Right? You import, quote unquote, import functionality from other modules inside expected keepers. We also added a couple of errors here and custom errors. But yeah, you could very quickly write something like this in span of like 2 or 3 hours if you're doing it from scratch and you're not talking in camera. And yeah, Starport allows you to quickly build these sort of applications, and of course more complex applications. as well. But this just shows how easy it is to model something and then just start typing away and adding functionality to your blockchain application. And that concludes my presentation on this.
So thank you, Dennis. Thanks, Tobias. Thanks, everyone, for being here. Again, there's been some links shared. We're running a October Code Fest. Starport is part of it. The link is there. In the announcement section, there's some other items like the Starport Discord, so check them out. And we will be back here in 1 month for another Starport community call. And hopefully you guys can add to the agenda, and we'll hear more about Dennis's vision for Starport and what's coming up next in the next version. But please do sign up for the mailing list, because this will be a way that we can update you on a weekly basis of what's coming down the pipeline in Starport. And this will be recorded and put on YouTube as well for anyone who couldn't make it. So I think with that, thanks everyone. That's a wrap.
Thanks so much for watching.
Thanks, everyone.
See you next time. Bye.